Hello students, today we will see rule number 5 and rule number 6 for drawing root locus. Okay, so rule number 5 is center of asymptotes, that is also called as centroid. Okay, so what is formula for centroid? Centroid is given with sigma c. So formula is summation of real part of poles of open loop transfer function minus summation of real part of open loop transfer function zeros upon n minus m. Okay, so what is centroid? A point of intersection of asymptotes with real axis is called as centroid. Okay, see in rule number 4 we have calculated angle of asymptotes. Okay, in previous lecture we have taken the example where we got two angles as beta 1 is equal to 90 degree and beta 2 is equal to 270 degree. So what I will do, see suppose I got here beta 1 as 90 and beta 2 is equal to 270 degree. Okay, so I need some reference point from where I can show this beta 1 and beta 2. Okay, for that I need to calculate the centroid. So what is that centroid? A point of intersection of asymptotes with real axis is called as centroid. In previous example, how many asymptotes are there? N minus m, we got 2. Okay, so as two asymptotes are there, there will be two angles beta 1 and beta 2. Okay, so see again I am considering the same transfer function g of s h of s as k upon s plus 1 s plus 1 s plus 2. Okay, for this transfer function we have calculated beta 1 is equal to 90, beta 2 is equal to 270, that is called as angle of asymptotes. Okay, so see now we need to calculate the centroid, that is point of intersection of these asymptotes. Okay, so see here sigma c is equal to summation of real part of poles. So these are the poles. You can see that here this pole is at origin, summation of real part of poles. When I will equate it to 0, I will get the number of poles at minus 2, minus 3. So summation of real part of poles minus summation of real part of 0, that is minus 1 upon n minus 1. What is n? N is equal to number of poles. So how many poles are there? 3. How many zeros? M is equal to 1. So 3 minus 1 is 2. So here I am considering n minus m as 2. Okay, so how much I am getting? I am getting sigma c as minus 4 by 2. So that is minus 2. Okay, so I got centroid as minus 2. Okay, so see now I know that this is sigma j omega axis. So as I got sigma c as minus 2, so I will show here sigma c as minus 2, and from this point I will locate beta 1 as 90 degree, beta 2 as 270 degree. So I will put my protractor here. Okay, and I will consider the positive real axis as reference axis. So from this I know that 90 degree will be here. Okay, so see I will draw the line here. So this line will give me the angle as beta 1 as 90 degree. Okay, and I have to show 270 degree. So see 90, 270, and I need to show one more line that will give me the angle as 270 degree. See this beta 2 I am getting as 270 degree. Okay, so I hope you are getting this. Centroid is nothing but point of intersection. What is point of intersection of asymptotes? We have two asymptotes, n minus m is equal to 2 here. Okay, so we have two asymptotes, beta 1 90, beta 2 270. So this is called as a point of intersection, that is nothing but centroid sigma c, and we got sigma c as sigma c is equal to minus 2. Okay, so I hope you got rule number 5. Now let's see rule number 6. Rule number 6 is very important rule, that is called as breakaway point or break in point. Okay, so generally this rule is calculated if two adjacent poles or two adjacent zeros are there. Please underline this statement. This rule is calculated, or you will get a valid breakaway point or break in point when two adjacent poles and two adjacent zeros are there. So see here I have shown, or I have taken one example. So I am assuming that, let's see that minus 1, minus 2, these are two poles. Okay, So as we have studied, the root locus will always start from pole and it will terminate at 0. Okay. So for this example, if in transfer function only 2 poles are there, so what will happen? And total number of root locus will be 2, because we have studied from rule number 2, whatever is greater, here n minus m is suppose greater and you have the total number of root locus as 2. Okay. And if there is no 0, in that case what will happen? Total number of root locus is equal to 2. So root locus will start from pole, and if 0 is absent, so it will terminate at infinity. Okay. So I hope you are getting, if the root locus is starting from pole, so this is my pole, so it will terminate at infinity. Okay. It may terminate at infinity. The second root locus may start from this pole and it may terminate at infinity. So what will happen? As 2 poles are there, so root locus will start from pole. So what will be the direction? Direction of root locus is going outward, or it is going outside, that is called as outward. Okay. So when root locus is going outward, then it is called as breakaway point. Okay. See, the procedure for calculating breakaway break-in is same, but generally the breakaway term is used for 2 adjacent poles. Okay. Now in second example, you can see that suppose I am taking -2, -3. Okay. If 2 zeros are there, these are 2 zeros that I have located. So I know that root locus will start from pole and it will terminate at 0. Okay. So root locus has started from somewhere pole. Now it is terminating at 0. Okay. So the root locus will enter inside. So this will be the direction. Okay. So you can see that this point of intersection is called as break-in point. So generally the word breakaway is used for 2 adjacent pole, and this word is used for 2 adjacent zeros. Okay. So see, what is formula for calculating sigma b? See here. Here I am saying that the point of intersection of asymptotes, is called as centroid, and that centroid is denoted with sigma c. Okay. And this is point of intersection, okay, of root locus with real axis. Point of intersection of root locus with real axis, that is called as breakaway / break-in point. And what is procedure here? That is represented with sigma b, b for breakaway or break-in. Okay. So see here, you need to calculate characteristic equation, or characteristic equation can be represented with the same way. D of s is nothing but denominator, d of s plus k times n of s is equal to 0. Okay. So see, again I am considering the same example, that k s plus 1 s plus 2 s plus 3. This is my example. So see, first step for calculating sigma b is arrange the transfer function or arrange the characteristic equation as k is equal to denominator upon numerator. Okay. From this, so this will be minus d of s by n of s. Okay. So next step, you need to take the derivative dk by ds and equate it to 0, so that you will get a breakaway point. So this is standard formula to get breakaway point. Okay. So we will see here, I am considering this transfer function. This is my d of s. See, this is my d of s and this is my n of s. Okay. So I am substituting as k is equal to minus d of s. So see here, minus denominator upon n of s. Okay. So I got k. Then I will do dk by ds is equal to 0. Okay. So I am differentiating second derivative of first upon first derivative of second upon second square. Okay. So as you know that here s cube term is there. Okay. So there will be definitely 3 roots. Whatever answer you will get, there will be definitely 3. Okay. So here I have shown here only 1, because the remaining 2 roots whatever I am getting are not valid breakaway. Why I am saying the valid breakaway? When you will locate this transfer function, in S domain. See here, s is equal to 0, then here 1, then -2, -3. So this is -2, -1, 0, and this is -3. Okay. So see, in rule number 3, we have seen that region on root locus. In that, what we got here, this is the portion that is region on root locus. For that we have taken point P1 and we got odd term. So this is the portion or region on root locus. Here we are getting even. So this will not be portion on region on root locus. Here see, 2 adjacent points are there. So here when you will put P3, so addition is 3, that is odd number. So this is region on root locus. Okay. So see, what is important from rule number 6, whatever value you are getting, suppose here you are getting 3 answers because of 3 roots. So you need to calculate the valid breakaway point. See, here I am saying the sigma b as valid breakaway because I am getting minus 2.45. So what I will do, I will check whether that minus 2.45, suppose let's assume that this is minus 2.45. So minus 2.45 is lying on region on root locus. Okay, so this will be valid breakaway point, and whatever 2 values you are getting, this may be within this portion minus 1 to minus 2, you can calculate. Or we have seen that from minus 3 to minus infinity, again this portion is not on region on root locus. Okay, so see, the important thing for calculating breakaway point, first of all you have to rearrange the characteristic equation in the form k is equal to minus d of s by n of s, then take dk by ds, equate it to 0, find out the roots, and that roots are nothing but the breakaway point. Okay, so breakaway is nothing but a valid breakaway point. Suppose you are getting 3 roots, so out of 3 roots you have to check whether that root you are getting is lying on region on root locus or not. So that will be only the valid breakaway point. Okay, thank you students.